Yes, hello everyone in the house, and welcome back again on another questions here. So these questions now is under frictional force, as you all know. Then we have a diagram here. The diagram here shows the mass of a body, which is 20 kilogram. Then the upward sloping force, which is the limiting frictional force, that is 40 Newton. Then the angle of inclination is 30 degree. There's an angle here inclined to the horizontal platform, that is 30 degree. Now the question is this: what is its acceleration down the plane? That is, looking at this diagram, observing this diagram, you are being asked to calculate the acceleration of the body down the plane. Now let us sight and work on this diagram. That's our first step. Looking at this upward sloping force, let's call this to be Fu. Fu represent the upward sloping force, which is the limiting frictional force. While the downward sloping force, let's call this Fd, or you call it the parallel force component. That is the Fd, downward sloping force. But we need to find the Fd here, the downward sloping force. Well, downward sloping force now equals to mg sine theta. That is the formula. The downward sloping force is mg sine theta. That is the force along the plane, the force parallel to the plane, or the parallel force component. That is the formula, mg sine theta. So that becomes m. Here is what is the value of m? M is 20 kilogram. Then g remains 10 meter per second square. That is the acceleration due to gravity. That is 10 meter per second square. While the angle of inclination is 30 degree. Now this is the parameters. Then input these parameters into this formula. We now have 20 times 10, then sine 30 degree. 20 times 10 gives 200. Then sine 30 is 0.5. So the answer gives 100 Newton. That is the downward sloping force. So the downward sloping force is 100 Newton. We are not done yet. We still need to calculate the effective force. So the effective force now is the change in the downward sloping force and the upward sloping force, which we now have. Effective force or net force equals to Fd minus Fe. So which is equal to 100 minus 40. So the answer gives 60 Newton. So that is the effective force here. Now from effective force now, you can now apply the formula that connects the force, which is the effective force here, the mass and the acceleration. And what is that formula? The formula is this: F equals ma. This mass times acceleration. Mass times